Hello friends, my name is Ogodino Uche Jude. Welcome to today's online class. Our topic for today is differentiation techniques. That's techniques of differentiation 2. We are going to start up from where we stopped in the previous class. So let's go through our lesson objective. So our lesson objective, at the end of the lesson, the student should be able to differentiate trigonometric and inverse function, differentiate exponential function, differentiate higher derivative of explicit function up to d raised to power 3y all over the x cube, or the cube y all over the x cube, differentiate logarithmic equations or functions. So before we go into these trigonometric functions, let's go back to where we stopped in the previous class due to some interruptions. So in our previous class, we were talking about implicit differentiation. So let's start all over. Our solution so the first one is x squared plus y squared equal to 4. So we said differentiating this now individually, that's d over the x of x squared plus d over the x of y squared is equal to d over the s of this. So differentiating this will give us 2x plus, if you differentiate this will give us 2y, that's 2 minus 1, 2 minus 1. So that will give us, now if you differentiate y, you are going to write the y over the s because you are differentiating y, equal to differentiating constant gives us 0. So we said that 2y dy over the x will be equal to, this one will move to the other side, that is minus 2. So the y over the x will give me minus 2 over, that's this 2x minus 2 over 2y. So if you cancel out, the y over the x will give minus x over y. So we are done with that. Let's try the next one. So the next one, I chose C then. So that is 4y square x minus 5x square y cube plus 4y equal to 0. So if you are differentiating individually, before you differentiate, bring out the constant. The constant is 4 into y square x minus 5 into x square y cube plus 4y is equal to what? 0. So I said, if you are going to differentiate it, first differentiate y and leave s. So let's leave s. You are leaving s, but you are differentiating y. So that will give us 2y dy ds. dy ds. Don't do anything to s, you leave s. Plus, now write this, then differentiate s. If you differentiate s, that is 1. So we are through with this first part. Then we'll go to the negative part, minus 5 into, now differentiate this first, that will give us 2x, then don't differentiate the second one, that is y cubed, plus, now write this, don't differentiate because you've differentiated the first time, differentiate this, that will give us 3, let's put dots here to show that they are multiplying, so that will give us 3y squared. That gives us 3y squared dy ds. Then plus, if you differentiate 4, if you differentiate 4y, you are going to get ordinary 4. But because you differentiated y and not x, you still write the y over the x equal to 0. Hope you understand this part. So the next thing we are going to do now is what? We are going to multiply out. So 4 times 2, this x will come here. Okay, let's write it very clearly. This will give me 4 into x or 2xy. This x will come here. the y over the x plus this times this will give me y square, then minus the next one should give us what? 5 into, yes, 2xy cube plus this 3 will come over here, 3x square y square, the y over the x, then finally plus 4 the y over the x equal to 0. So multiplying out now, what we got there, multiplying everything we got here now, 4 times 2 give us 8xy dy over the x plus 4. 4 times this will give us what? Have we done the right thing now? Oh, I think I missed something here. Differentiated. Okay, I didn't miss anything. It was differentiated out. So that will give us 4y square. Then minus this will give us minus 10xy cube. Minus times minus will give us minus 15x square y square the y over the x. Then plus 4 the y over the x equal to 0. So collect all the ones with the y, the s on one side. The other one should move to the other side. So this gives us 8xy dy over the x minus 15x square y square dy over the x plus 4 dy over the x equal to, this one will move here, this will move here. So this was plus now. Moving to the other side, minus 4y square. This one will turn to plus 10xy cube. So what do we do now? Factorize the y over the s. The y over the x comes out. This becomes 8xy minus 15x square y square plus 4 equal to minus 4y square plus 10xy cube. So if I clean this, I don't want to use this place because it's not wide enough. So if I clean this place now, this becomes what? Divide both sides, make the y over the x the subject of the formula. So you divide both sides by this. So the y over the x will give us minus 4y squared plus 10xy this all over 8xy minus 15x squared y squared plus 4. So that is our final answer. That's our final answer. So with that, hope you understand what I've just done. Okay. So trigonometric differentiation example 1. So further mathematics example 1. Find the derivative of the following. Find the derivative of the following. So the following are, I'll pick 2, cos square xb sine 1 over 3x. So now the solution to this is you are going to use chain rule. Cos square x, y is equal to cos square s. So you separate, y is equal to cos x square. That is the actual meaning of this. If you have cos s times cos s, it's not going to give you cos x square, but cos square x, meaning you multiply 2 times. So if I put this in brackets, it means cos s times cos x. So what you do now, your u will be equal to what you have in brackets. U is equal to cos x then the u over the s is what? So from your differentiation table, if you sine x, if you differentiate sine x, you get cos s. When you differentiate cos s, you get minus sine x. So our y, you now say y equal to, you use u to represent it, but your y will be equal to u raised to power whatsoever you have raised to power 2. So the y over du, like you've known the language already, u and x, du over the x, meaning differentiating u with respect to x, while u differentiating y with respect to u. So bring down 2, u2 minus 1, that is 2u. So our chain rule formula is the y over the x is equal to the y over the u times the u over the x. So that gives us what? What is my the y over the u? That's 2u times, this one is what? Minus sine x. So this gives us what? 2 into, what is my u now? My u from the beginning is cos s, then minus sine x. So bring the minus over to this side. So that gives us minus 2 sine x cos x. Or you can leave it as minus 2 cos s sine s. So that is the answer to the first one. Okay, let's solve the second one. So our question, y is equal to sine 1 over 3x. So our u is this part. U is equal to what? 1 over 3x. Then the u over the x will give us what? There is a visible one here. So 1 times 1 over 3x, 1 minus 1. So that gives us 1 over 3, right? Because this will be x raised to power 0, 1 over 3. So our y is equal to, you remove this, so that is sine u. So dy over du will give us, from your differentiation table, logarithmic differentiation table, if you differentiate sine x, you get cos x. So if you differentiate sine u, that means you're going to get cos u, right? So our dy over the x will give me dy over the u times the u over the x. So what's my dy over du? That's cos u times du over the x is what? 1 over 3. So that's cos, what's u? Your u is 1 over 3s times 1 over 3. But this 1 over 3 will come here. So that will be 1 over 3 cos 1 over 3x. That is our answer. So moving ahead, so derivative of logarithmic function. Example. So I'll copy the example before we go to solution. Example 2. Find the derivative of each of the following. So the first one is y is equal to log a 3x plus 2. The second one is y is equal to log e 4x minus 1 square. So we stop share. So the solution, y is equal to log base a 3x plus 2. So your u will be this part, 3x plus 2. The y, oh sorry, the u over the x will give us 3, because this one give us 0, bring down 1, and so on. Our y will now be equal to log AU, right? This one has gone out, so you replace with u. So our dy over du will give us 1 over u log AE. So when you differentiate log, whatsoever you have here will come over to the front as the inverse, log A. The space left will be taken by exponential. So our dy over the x now will give us dy over the u times the u over the x. So what is my dy over the u? That is this 1 over u log AE times, this one should give me what? 3, right? So that is 3. So the u over the x is 3. So this times this will give us 3 times 1, 3 over u log AE. So the only thing you just need to do now is fixing the value of u. What is u? 3x plus 2. So that will be 3 over 3x plus 2 log AE. So that is your answer. So going to the second example. Example 2, solution. So y is equal to log base exponential 4x minus 1 raised to power this. So we still follow the same procedure. Our u is equal to 4x minus 1 square. So du over the x will be equal to, remember, you are going to use chain rule for this. So let's use the short method of chain rule. So du over the x will give me, bring down 2 into 4x minus 1, 2 minus 1 times. If you differentiate this, what are we going to get? Ordinary 4. So 2 times 4 will give us 8 into 4x minus 1 raised to power 1, which will go off. So that is our d over the x. Then y is equal to, what is the vacant space left here? Log E. Once this one is removed, you replace with u, right? So the y over du will now be, this one will come here as 1 over u log E. Always replace here with E. Now in your log reading, mathematics, when you have log xs, that is 1. When you have log 10, 10, that is what? 1. That's log 10 to base 10. Log 5 to base 5 gives you 1. So the y over the u now be 1 over u times 1. This is 1, which is 1 over u. So we have 1 over u now. The other time, because we have a and e, that's why we could not convert to 1. Okay, now to continue now, our dy over the x will give me the y over the u times the u over the x. So what is my dy over the u? 1 over u times, this one is what? 8 into 4x minus 1. So that will give us what? That will give us the y over the x is equal to 8 into 4x minus 1 all over. My u was 4x minus 1 square. So this cancel this, it will remain 4x minus 1. So the y over the x will give me 8 over 4x minus 1. So this is your answer. So moving ahead to the next one. Derivative of exponential functions. Derivative of exponential function. So find the derivative of the following exponential function. So this is example 3. A e raised to power 2x, b e raised to power and x. So this is very straightforward and simple. So if you are solving exponential, the first one, solution, y is equal to exponential 2x. So my u will be equal to this when you are solving exponential 2x. The u over the x is what? 2. should know by now 1. 1 times 2, 1 minus 1. So we get 2. Now, my y will be equal to e raised to power. 2x was taken to represent u. So this time around, the vacant space replaced with u, right? So the y over the u will give me eu. If you differentiate exponential, ex is ex. So if you differentiate eu is eu. Check your logarithmic table for differentiation. So that is eu. So our dy over the x is dy over the u times the u over the x. So what is my dy over du? My dy over the u is e raised to power u times d over the s is what? 2. So that gives us 2 eu. But you can't stop here. That gives us 2 exponential. What is u? U is what? 2x. So that is that for that. Okay, let's solve the second one before I move ahead. So the next one, y is equal to e tan x. So your u is equal to tan x. This is your u. Then du over the x is equal to what? Sec square x. If you differentiate tan x, you get sec square s. So our y is equal to eu. The y over the u will give us eu back. So the y over the x is equal to the y over the u times the u over the x. So what's my dy over the u? EU times d over the x is sec square x. So the sec square x come forward, sec square x, or okay, no exponential. Let's leave it as exponential. Sec square x. Then what is my u? My u is tan s. My u is what? Tan x. So that is your answer. So higher derivative. Okay. Yeah, in the final one, higher derivative. So how do we solve this higher derivative? Very simple. So the question is find the first, second, and third derivative of each of the following. Find the first, second, and third derivative of each of the following. So I'll pick the second and the last one. The first one is simple. So solution, y is equal to 3x5 minus 2x4 plus x squared minus 1. So what this actually means is the y over the x is the first derivative. 5 times 3, 15. X, 5 minus 1, 4 minus 2 times 4, 8x, 4 minus 1, 3, plus bring down 2, x, 2 minus 1 is 1. The differentiate constant is what? 0. So the second derivative is the square y over the x squared is equal to, meaning differentiate again. 4 times this will give us 60x, 4 minus 1, 3, minus 3 times 8 is what? 24x, 3 minus 1, 2, plus, there's a visible one, 1 times 2, 2x, 1 minus 1. So that gives us 60x cubed minus 24x squared plus 2, because this is 2 raised 0, and anything raised to power 0 is what? 1. So 1 times 2 will give us 2. Then they didn't say we should stop at the second derivative, meaning we are going to differentiate again. The cube y over the x cube is equal to 3 times this one will give us 180x squared minus 2 times this should give us 48x plus 0. So this one goes up. So this is our final answer for the first one. So solution to the second one, y is equal to ln s. So the y over the x of ln s, check your table, is 1 over x. So if you want to get the square y over the x square, meaning we are going to change this to negative index to make it very easy and possible. So bring down minus 1, x into minus 1, right? So minus 1x minus 2. So you can decide to turn this one upside down if you want to. That gives us minus 1 over x squared, right? So the square, the cube y over the x cube is equal to, so this is the part we can actually use. So if you're going to do this now, then this means that this times this will give us 2x minus 2, because minus times minus will be what? Plus. 2 times 1 is 2, minus 2 minus 1. So that gives us 2x minus 3. So you can actually write this as what? 2 over x cubed. Why? Simple reason is because 2 times 1 over x cubed. This is the same thing as this. So it gives you this. So with that, folks, we come to the end of today's lecture. So with that, folks, we come to the end of today's lecture. Hope you understand what I've taught you today. Please continue practicing. Until we meet again in our next class, stay safe. Arrivederci.